Okay, hello everyone. So I'm going to solve a differential equation by using RK4 method, Runge-Kutta fourth order method. All right. So let's get started. So let's see. I always start with this clearing everything, command window and as well as workspace, or if there is any figure on. Okay. Fine. So I'm going to consider a function dy by dx is equal to y into cos x, cos of x. Okay. This is I'm going to solve it for initial condition y at x equal to 0 is equal to minus e. Okay. So I'm going to match the exact solution as well as with the RK4 method both. So let me just start. So firstly, we need to define this function. So this dy by dx we are going to assume as f of x comma y, right? X comma y. So let's just assume f is equal to. So the way we define directly a function in MATLAB, we just write f equal to at x comma y and then y into cosine of x. All right. Fine. Now this is our function that we defined. We are going to take. Okay. By the way, I would advise that just go through RK4 method. Okay. Look at some formula, mathematical formulation, basically algorithm. Although I will explain, so you do not need to see that. But if you know already, that is better. So let me take h equal to 0.01, which is small enough by the way, and I'm going to take x from 0 to uh, so 0 to 2 pi I'm going to take 2 into pi. All right, fine. Now, so what we need to define the initial condition as well. So initial condition, so you can see here y of 1 is equal to exponent of minus 1. This is easier this way. All right. So y of 1 because it's first array of y, first value of y, that is why index is 1. So we cannot take 0 index because MATLAB doesn't support that. Okay. Now let's just define the RK4 algorithm. I hope you are with me here. I equal to 1 to length of where length of x but little less than 1, length of x minus 1. Okay, because we need to solve it for y of I plus 1 and we can only go to the length of x, that is y. Okay, let me just end the function. Now we need to solve k1, find k1, and k1 is nothing but f of h into f of xi comma yi. All right, I hope you understand. Now we need to find k2 equal to h into f of xi plus xi plus h by 2 actually. All right, comma, by the way, so yeah, let me just put it in a bracket, this would make sense. Then again yi plus k1 by 2. All right, so this is just the algorithm, nothing else, and I'm just going to copy paste it again twice just to save time and then I'll edit it. So I need k3, right? So when I will find k3, it would be nothing but this would be as it is, and here yi plus k2 by 2, and for k4 this is going to be k3 and this is going to be K4. All right. Now I need yi plus 1 is equal to yi. This is basically discretizing dy by dx. Okay. So although this formulation is you know RK4 itself 1 by 6, so this is weighted average of all the k's. Okay, so that would be k1 plus 2k2 plus 2k3 plus k4. All right. As you can see, 2 plus 2 4 plus 2 6, so it is kind of weighted average, weight of which is fixed for this RK4 algorithm, right? Now you are going to have y for every x. Sorry. Okay, so we kind of actually solved it. Okay, now since let me just plot it, right? uh, Figure 1, and then plot what we need to plot: x comma y comma, let's say uh, color. These things are not needed, I'm just doing it for fun. So line width comma, I always take 1.2. This is dark enough. Okay, let me just hit the run editor. Fine. All right. So this is okay. Now, now what we need to do is we need to, let's just compare it, right? So what can we do to compare? So I have already solved this differential equation for those given condition, and let's find exact solution. So once you find exact solution, you will see that, see, I'm just going to explain it very quickly. So since dy by dx is equal to y into cos x, it is explicit function. So take y on this side, it would be ln y equal to so it is cos x, right? Yeah, actually let me take it sine. All right, this would be in sync with what I have planned. So dy by dx is equal to y equal to, nothing changes. You can do that with that also. It's just initial condition I had decided like that. So you'll see here that okay, yeah, this is the function and this is the plot I was expecting. Okay, now once you find the solution through exact method, how, what would you do? Dy by y is equal to sin x dx. So ln y is equal to minus cos x plus c, and then y equal to e to the power minus cos x, and then you'll find then you will find some value of the constant. Okay, so what can you do here? Yeah, let's find the exact solution here. The exact solution would be what? So I'll just briefly explain it. So ln y was what? Sin x. So minus, so integration of sin x would be minus cos x plus some constant c. So y is equal to what? E to the power exponent of minus cos x plus c whole. So at x equal to 0, what is the value of y? Y is minus e. So at this would be exponent of minus 1 into uh, exponent of minus 1 into e to the power c, right? This would be 1 upon e into e to the power c. Basically I'm solving, just hang with me here. So this would be e to the power c is equal to minus e to the power whole square. So I can just take plus e instead of minus e. This would make my task easier. So c equal to 2, basically y would be So our exact solution would be, I'll tell you what. So I'm basically making sure that whether the function that we have plotted matches or not. So this is f exact. So our solution is going to come as y equal to exponent of minus cosine of x plus 2. So value of the constant was coming 2 if we take plus e. Okay, all right. Now we need to find this f exact is equal to, so let's just say y exact, y exact of I. Okay, we need to make some loop I equal to 1 to what, length of, yeah, length of x, right? So this would be, and here exp of minus cosine of x of I. All right, so plus 2. If the solution is incorrect, let okay, so what I need is, this initial condition is supposed to be y0 equal to e, and I was missing here exponent 1, so I kept changing here, but that was commented and I needed to change here e to the power minus 1, right? Now so this is exponent, and just fast forward the videos. So exponent minus of cos xi plus 2. So coefficient value of the constant was coming plus 2. I just solved it. So yeah, it was very easy, but fine. I made some very quick mistake. Okay, so in order to just match it, what you can do is, let's just put this sign so that you can see that both the solutions are matching on top of each other. Okay, so oh, okay. So since solution is coming on a different window, you may not be able to see it. All right. So let me just, you can plot it in your computer and see, and hopefully I will put the, let me just save. Hopefully I will put the plot. Okay, in the beginning only. So I'll save it. Save as. Save as. So you can save it like this. So GCF comma solution dot, let's say, png. So that should be in single comma. Fine. Now you can see, so the plot is saved here. Here you can see. So you can follow the same to match it. Let me know under the comment section. Thank you.